Gonna talk about extremer on an interval. Where can the highest and the lowest point be on an interval? So we have an interval from A to B. And maybe it's open at A and is closed at B. This highest point, and let's call this f of x, the graph. The highest point occurred when the derivative was 0. Had a horizontal tangent line. The lowest point occurred when the derivative was 0. But does it always have to be when the derivative is 0? And the answer is absolutely not. For example, this curve right here, the derivative is 0 here and here. But you know what? Let me just draw this a little bit differently, please. The derivative up there is not 0. And let me draw this one a little bit differently. In fact, let me draw the whole thing a little bit differently. Suppose the function goes like this. And here's A, and right there is B, and it's closed off. Well, right here the derivative is 0, and right here the derivative is 0. But the highest point was at A. The lowest point was at B. Of course, I can flip over this graph and I can have the lowest point at A and the highest point at B. Here's A and here's B. Now, let us consider what happens in this situation. What if you have this graph? Here's A and here's B. It's closed at A, but it's open at B. So clearly, and this is y equal f of a, sorry, f of x. Clearly, on the interval AB, f of a is the least. But first of all, there is no f of b because it's undefined, hence the circle. So you're going to say, well, yeah. So it's going to be the number before. Well, there is no number before. You know, that is, maybe the height right here would be 70. So you're going to go, okay, so it's 69, the highest point. Well, no. What about 69 and a half? That's 69. That's 69 and a half. That one up there is 69 and 3/4. I can get as close to 70 as you like. I mean, after all, let's just blow it up. If this is 70 and this is 69, so you say, well, it's 69 and a half. Or maybe you say it's that mark. Well, then I'll say, what about the average of the two? You go, yeah, you're right. That's the number right before 70. Well, it's less than 70. So you take the number, you take the average of two numbers that aren't the same. You will find a number in the middle. That's why we call it average. So that's the highest number before 70. No, it isn't. I'll pick the one in between. No, it isn't. I'll pick the one in between. I can do that forever if my marker wasn't so thick. But you can always pick a number in between two different values. So there is no max point on this curve, but there is a min value. What's the min value? Well, whatever marking is right there. Whatever f of a is. but there is no max. Likewise, if there was a hole at 0, then f of a doesn't exist. So this function has no max or min. It's not here where the derivative is 0, and it's not at that point where the derivative is 0. Why? Because I found lower points. All of these points are lower. Okay? All of these points are higher. All of them are higher than this one. Okay? This one would have no max or min. If I filled this in, it'd have a max, but not a min. So the derivatives can only occur at an endpoint or a max, or where the derivative is 0? Maybe not. What if you have a function that goes like this? It'll be filled at A, it'll be filled at B. Well, the max is right there. But f prime of x, it being a corner point, f prime of x doesn't exist there. That is, if this were C, I guess it would be more correct to say that, that f prime or C doesn't exist. But it's the max. Did it have to be the max because derivative didn't exist? I mean, that's absurd. I can go higher than that, and maybe that's B. If you say, come on, you can't change it, B is there. Well, I'll just change more steeply. I'll change more steeply. It goes like that. So B is the max, and A is the min. So you have to check the endpoints and where the derivative is 0 or undefined. You have to check all of those. You have to find the absolute max and the absolute min. You have to check the endpoints, even if it's not defined there. You have to check the endpoints and the critical points. That is, where the derivatives equal 0 or undefined. So let us do some formal problems. I'll give you a function, I'll give you an interval, I ask you to find the max or mins. So they're all find the extrema for f of x equal 7x plus 5 on the interval -2, 10. Now, the thing here is you have a line that has a slope other than infinite and other than 0. The line either goes like this or it goes like that. Since it's positive, it goes like the first one. But the problem is that, great, excuse me a moment. The problem is the lowest point is at -2 and the highest point is at 10. But none of those are included. Same thing if it happened to go this way. Here's -2 and here's 10. If it's not included. So lines better include the endpoints. But if you wanted to do it more formally, I mean, I would personally, I would just draw, if this was an assignment for me, say on a test, I would draw this graph. When x is 0, y is 5. When x is 1, because 7 times 0 is 0, plus 5 is 5. X is now 1. 7 plus 5 is 12. Okay. Actually, I guess I would, I guess I would plug in -2 and 10. I take that back. I apologize. When you plug in -2, you're going to get negative 14 plus 5, which is negative 9. So you're going to have this point, and if you plug in 10, you're going to have 70 plus 5, which is 75. Let's say it's those points, okay? Now, the thing is it goes like this. It should cross that 5. Let it go, please. Okay, let me cross that 5. Okay, that's 5. All right. The thing is that this would be the lowest point and that would be the highest point, but we're not including them. So that's how I would do it. But if you want to do it more formally, that is in the spirit of their section we're in, you take f prime of x, which is our 7, and you set it equal to 0, and you set it equal to does not exist, and 7 is never 0, and it never doesn't exist. Okay. Then you look at f of negative 2, and you look at f of 10. Well, and the f of negative 2 was what? Negative 9, and f of 10 was 75. So this would be the max, and this would be the min, but we're going to say no min and no max, because you can take f of those values. Okay. That was a little bit confusing, but it will become clearer when we do the next couple. So suppose you're told that f of x is equal to x cubed plus 3x squared plus 3x plus 29 on 0, 2, open 2. We want to find the extreme values, the highest and the lowest. So we have to find the critical values. F prime of x is 3x squared plus 6x plus 3. Let's factor out the 3 to make it clearer how to factor it. Ooh, that's x plus 1 squared. And this equals 0. Well, 3 is never 0, so it's going to be 0 when x is negative 1. But we reject that one because it's not in here. Okay, so now all we do is we check f for 0 and f for 2, and the largest one is going to be the max, and the smallest one will be the min. Okay, possibly. What's f for 0? 0, 0, 0, 29. F for 2. 2 cubed is 8, plus 3 times 4 is 12, plus 6, plus 29. Clearly, it's the larger one. This one's going to be the min, and there's going to be no max, because you can't be 2. You can't be 2. What's going on is this is the cubic, which goes this way, but it has no max or mins on 0, 2, which means that, here's 0 and here's 2. F of 0 was 29 and f of 2 didn't exist. Or, of course, we could have had, 0 and 2 here. It's increasing. The problem is that f of 2 would have been the largest, but it's not there. It says it's open. So there is no max. Because this sum, whatever it is, I know it's bigger than this one. Either this is going to be the min if it exists, or that's going to be the max, or vice versa. Okay, it turns out that this was the larger one, and it failed because it doesn't exist. Okay, let us try another one. In fact, let's do this same exact problem, except we change the limits, or the range. How about the range becomes -2 to 2, but we include the -2. Okay, so we need to, so this equals, the derivative equals 0 when x equals -1. This time we keep it. So now we want to find f of the critical values. We keep it because it's in here. And we want to check f of 2 and f of -2. Well, f of -1, you plug in -1, you get -1. You plug in -1, you get 3. You plug in -1, you get -3. So that's going to cancel. Plus 29, you get 28. F of 2. 2 cubed is 8, plus 2 squared is 4, times 3 is 12. 3 times 2 is 6, plus 29. Well, it's bigger than that one. Maybe we don't have to figure it out. Maybe we do. F of -2, well, that's going to be -8. And f of -2 is going to be 12. And 3 times -2 would be -6 plus 29. Well, we kind of have the same numbers here, but in the top we're always adding them, and in the bottom sometimes we're subtracting. So actually we're going to have to figure out what this is. This is 4 minus 6 is -2, so that's 27. So that's going to be the min, and this is 20 and 35. That's 55. And you're going to have a min. Now, let us just be sure now. The min, the possible min, occurred at -2, so we can keep it because it's closed. And the possible max, let's write max. The possible max occurred at 2, but we're not including 2. It's open at 2, so there is no max. This function has no max. It does have a min. You can get different answers by changing the interval. For example, if I say -2 to 2, then we would have a max, and it would be 55. Let us try another one. Suppose you have that f of x is equal to 3x to the 2/3 minus 2x, and we're talking about the interval -1, 1. So let us find the derivative. F prime of x is, bring this down, the 3's cancel, make the new power 1 less. 2 minus 3 is -1. Keep the denominator. Minus 2. Well, I can factor out the 2. So I have x to the -3rd minus 1. Well, that's 1 over x to the 3rd minus minus 1. All right. Now, this is undefined when x equals 0. Okay? And it equals 0 when this equals that. When 1 over x to the 3rd equals 1. Well, I'm going to write up here, please. If you have any fraction that equals 1, then the top and the bottom are the same. That is those two are equal. X to the third equals 1. Well, that happens when x is 1. When x equals 1. Now, 1 is in this interval. I would say it is in the interval even if it was open at 1. And x equals 0 is in there. So we need to check the two endpoints and the critical values. We have to check f of -1. We have to check f of 1 because the endpoints, that one I already have on the list, and I need to check f of 0. Let's do f for 0. 0 to a positive power, because if it was a negative power, then it'll be like 1 over x to the 5th. When x is 0, that's not defined. But if you have x to the 5th, or even 1 over x to the -5th, it equals that. And 0 to the 5th is 0. But 1 over 0 to the 5th, that's undefined. Okay, so where are we? So this is 0. Times it by 3, you get 0. Take away 2 zeros, you get 0. Okay, what is f of 1? Well, you have 3 times 1 to a power minus 2 times 1. 1 to a power is 1. So this is 3 minus 2. We get 1. What about -1? What if you have 3 times -1 to the 2/3 minus 2 times -1? Well, let us look at -1 to the 2/3 carefully. This is -1 squared and then raised to the 3rd. Why? Because -1 squared, or anything squared to the 3rd, well, you multiply the powers and you get 2/3, just like we're supposed to have. Now, the nice part is -1 squared is 1. This is 1 to the 3rd, which is 1. Times 3 is -3, plus 2 is -1. Okay, so we have a possible min. So I look for the smallest number and the largest number. We have a possible min of -1, and we have a possible max of 1. Okay, now, were we able to find f of -1? The answer is yes, we can include it. And we can find f of 1 because it's included. So we have a max at -1, a min at -1 when x is -1, and we have a max when x is -1. Coincidentally, as long as I didn't make a mistake, the x value and the y value happen to both be the same. So you have a max y value of 1 and a min y value of -1. Let us try one more problem. Check the endpoints and check the critical values. So if you have f of x is equal to x cubed over 3 minus x squared over 2 minus 6x plus 1, and the interval is -1, 5, not including 5. And you want the extreme values. Well, you compute the derivative. You bring down the 3, it'll cancel with the 3 in the bottom, leaving x squared minus. Bring down the 2, it gets killed off with the 2 in the bottom, and you get x minus 6. Well, this turns out to be x minus 3 times x plus 2. The two numbers multiply out to -6, and they add up to -1. Well, this is 0 when x is 3 and when x is -2. Well, 3 is in this interval. That's good. But -2 is not. Okay. So now we need to check f of -1, f of 5, and if f of 5 is a max or a min, since it's not included, it's open, we're gonna reject it. And we also have to check f of 3, the critical values. So we get -1 cubed over 3 minus -1 squared over 2 minus 6 times -1 plus 1. That's -1/3 plus a half plus 6 plus 1. -1/3 is -2/6 plus a half is 3/6, so you get a 6. That's 13. So you get 13 and 1/6. When you plug in 5, 5 cubed is 125 over 3 minus 25 over 2 minus 30 plus 1. Let's get a common denominator of 6. I double top and bottom. That's 250. I triple top and bottom. And I get 175 over 6 minus 29. So this is minus 29 minus 1. Well, you know what? Let us figure out what 175 divided by 6 is. 6 into 175, it goes 2 times. With 5 left over, bring down the 5. Goes 9 times, that's 54, with 1/6 left over. Very good. So it's 29 into 6 minus 29. We just get 1/6. 1/6. And let us get rid of some of this scrap work so it doesn't really get in the way that much. Now, the question is, what is f of 3? Let's scroll up a little bit. F of 3, it's 3 cubed over 3, which is 3 squared, minus 9 halves minus 18 plus 1. So this plus this is 10, minus 18 is minus 18 minus this, which is 4.5. So it's -22.5. Okay, so now we are ready to define the largest and the smallest value. Clearly, that's the largest. That's a possible max. And this is the least. It's a possible min. Now, we see we plugged in -1. Oh yeah, we can include -1. So that is the max. F of 3, yeah, it wasn't one of the endpoints. It was in between. So that's okay. If it turned out that F of 5 turned out that X of 5 was 290, we would say no max because 5 is not allowed to be in there. But it wasn't 290, it was 1/6, and everything worked out nicely. This completes the video on Extrema on an interval. Once again, check f of, or g or h, depending upon the name of the function. So you have, say, I don't know, we'll change your name, g of x on AB. Doesn't matter if it's open or closed. You need to check g of A, you need to check g of B, and you need to check g of all critical points in AB. Why don't I include B? Because we're going to check g of B anyways. Okay? Now, one of these, maybe two of them, they can be equal, but we'll say one. One of them is going to be the largest, one of them is going to be the smallest. If this is the smallest, we reject it because it's not included. If this is the largest, we include it. If g of a would have been 11, the smallest, and g of a critical point was also 11, then 11 will be the smallest. What type of graph would that be? Well, here's 11, and we said the smallest. And here's A, and here's B. So maybe the graph goes, well, maybe the graph goes like this. It comes back down to 11, and then it goes back up. So there was another place where it was 11. So just because you're rejecting it because you can't include A doesn't mean it can't come up again. But the bottom line is, this is what you need to check what's in this box. You need to check G of the left endpoint, G of the right endpoint, and G of all critical points in the interval AB. Reject critical points outside the interval. See you guys in the next video. Thank you.